Today's topic is mechanics of solids, simply MOS. Under this, our first topic is stress and strain. So, any engineering materials that is used in engineering applications is based upon mainly two criteria. First one is strength and the other one is stiffness. It is also called as serviceability. And what is strength? So strength is a criteria which tells about resistance to failure. And what is stiffness? It's a criteria which tells about resistance to deformation. So what is stress and strains? So stress and strains as defined in terms of materials. Any material that is used in engineering applications is based upon two criteria. First one is strength and second one is stiffness or serviceability. So what is strength? Strength is nothing but it is resistance to failure, and stiffness is nothing but resistance to deformation. Next topic is assumptions in mechanics of solids. So what are the assumptions in mechanics of solids? First assumption is that materials of the body is solid. It is assumed to be solid and continuous. And next assumption is that materials of the body is homogeneous and isotropic. So what is homogeneous and what is isotropic? So first come homogeneous. A material is said to be homogeneous when it has identical properties, same at all points in same direction. That means this is a material and that material is said to be homogeneous when it has identical property, that is, it is having same property at all points in same direction. Okay, that is homogeneous. And what is isotropic? Isotropic is nothing but a material is said to be isotropic if it has identical properties at a point in all direction. That is, suppose we are choosing this as our point, so it is said to be isotropic if it has identical property in all direction. Okay, in all direction. So note that the properties considered while stating homogeneous and isotropics are elastic property. Okay, and the best example for that is Poisson's ratio, bulk modulus of rigidity, etc. And next assumption is that there is no internal force before loading. That is, there is no internal forces before loading. That is, we are going to apply some load over the material and we assume that there is no internal force before loading. And also self weight is neglected. Next assumption is very important, that is principle of superposition. That is, principle of superposition is valid for linearly elastic structure. That is, it is valid when deformations are linear functions of force, or can be said that it's valid when deformations are very very small. That is, principles of superposition is valid for linearly elastic structure, and as deformations are valid for if deformations is very very small, can be said like that also, and very small in case of in compared to the direction of structure and